So, willkommen. In this talk, I will be sharing with you my best tips and tricks to get even your legacy code under test or your spaghetti code. And I'll combine that with some experience reports from what we have done in the project I'm working on, and where we have done these things and how that went out for us. So the goal of this talk, like the thing I hope that you can take with you, each and every one of you, is that, okay, that you feel inspired and enabled to go home and test your legacy code, to get your legacy code on the test. My name is Mats Opheim. I'm working as tech lead in the Norwegian company Computas. We're a consultancy company. I'm really excited about test-driven development, about modern agile, domain-driven design, and as many of the people at this conference, microprofile. But in my professional life, the one thing I've been the most excited about, to like work the most with, is to get legacy code under test. So what do I mean when I say spaghetti code? So spaghetti code, it's a bit like the spaghetti I was making on this picture. It's like it's a bit unclear, so it's like hard to see what's going on and like how thing is coupled, and it is really tangled, so everything hangs together, and like if you want to change one thing, you might very well affect the entire system when you're doing it. So yeah, you might say that it's really another way to say legacy code, but like everyone's saying legacy code, so I had to say something else. And like as this title of this talk is to get how to get your spaghetti code under test. What do I mean by under test? Well, I mean it like in the Michael Fedder's working effectively with legacy code way, like write programmatic talks. Programmatic tests, automated programmatic tests. So like exploratory testing, like test complete, Selenium, or like graphical testing. That's cool. Keep doing that. But what I'm going to talk about today is like how to get programmatic tests for your code. Yeah. So what took me all the way from being a tech lead in Norway into going to Germany and speaking about testing legacy code? One might ask. I'm working as tech lead today on a project with 35 developers, or like 35 participants, including developers, but also like test leads and managers and so on. And when I started working, I was a junior developer at the same project. And the project had been going on for many years. Like we had an established way to do things, we had established guidelines for everything and so on. And one of those guidelines were that everything we delivered into production should be tested. And when we said tested, we of course meant manually tested. Like someone has to click through it. Like only through manual testing did we feel as safe and confident that what we were doing were actually working. And let me admit something for you when I'm standing here. I find manual verification, as that really is, to be really, really boring. Like open up our graphical client, because we had a huge Java Swing, yeah, just laugh. Java Swing client with like huge things. So going through a feature like, okay, to test this, you need to click here, write 15 there, and do something here, do something there, and like you had a tedious, detailed test description. Like you had to go through it manually. You went through it manually like after someone else had developed it, and then you went through it manually again in the system test phase, and the customer went through it again in the acceptance test phase. Like, yeah, even when like standing here talking about it, that makes me tired. Like this is, yeah, I don't like to do things like that. It's boring. I find development to be much more fun. But on the other hand, I don't like to cause bugs. I don't like stressful periods, like in the end of a system test period, like where you have like sit there and like fight bugs and run after them and fix one bug after another. Don't like doing that. I like creating great code with few bugs that helps our users in, yeah, lets them, that our system let the users do what they want to. And that is why I came into automated test. Yeah, and that again led me to this question, like how many times should you test your code? Like one important premise here is that with a test, you want it to give the exact same result every time you run it, unless there actually is something that's changing there. So if you're changing a source code, if you're changing a hardware, if you're changing like anything external dependency or something, yeah, then the result may be different. But like, if not, the test should give the same result over and over again. And if you set a human to do that manually, you won't get that, right? Because we humans, when we're doing repetitive things, we tend to lose focus, to be bored, like maybe take shortcuts, or like, yeah, pretend that we did it but we did not, or like anything like that. Um, so, and that's the thing that fascinates me, because as a developer, I love acronyms, of course, and like one of the acronyms that developers love the most is DRY. Don't repeat yourself. But isn't that exactly what we're doing when we're testing the same thing in the same manner over and over again? So I get that you may want to retest like that your components speak together, or like, yeah, this component and that component still can be able to talk together, but like the corner cases and all of these things, you shouldn't have to test that several times. So be deliberate about what you're testing several times. Is there no one here working as test leads, by the way? Testers? No. A couple, yeah, cool. Yeah, and this is what I just said actually. Like, we humans, we're flexible, we're full of good and bad ideas. We're like, we can do things in several different ways. We can be creative, flexible, and adaptive, but we're bad at doing the exact same thing over and over again. So let the computers do that. Because the computer is great at doing exactly the same thing again and again. So if we leave this repetitive testing and repetitive things where we're doing the same over and over again for the computer, then we have freed up time to do more development, or like more exploratory testing, or improving the test scripts, or like all of these things that makes our software better. Because like, I never heard about a development project where people don't have enough things to do, enough things they wish they could have done if they had more time. So let the computer do the automated testing. Yeah, so that's like the setting, the intro. Now I'm heading over to like the tricks, tips and tricks, techniques, call it whatever you want, that I often use when testing code, and like I want to share with you as well. So maybe you can pick up some of them, and maybe some of them are useful for the project you're working on. Like probably I assume that not everything's applicable for everyone, but that's the way it is. So your mileage may vary, but I hope that some of it will be applicable in your projects as well. And it's worth noting here that some of these tricks will improve your design and make your code base better, while others may be a like trade-off between testability and the ideal design you would have designed if you didn't care about testing. But that's a trade-off, so it depends on your code base and your language and all that. Yeah. All right. So the first trick, extract interface. Yeah. Like, and your IDE will of course help you with this. And yeah, this may be like rather C family specific, but this is Java conference, so I guess that's fine with you. But by doing this, you're making the API you're exposing from your class much more visible, much more clear for the other ones using it. Because one thing you might not be thinking about is that every code you write is actually an API for someone else to use, like for the next developer, which is going to use the code you're writing. You are, in a sense, writing an API anyways, and if you're using an interface, you're making it explicit what you expect from them. You're making it explicit what the guys using your code should do. So let me give you an example here. Here you can see to the up left, here you see a class. Oh, the name of it is hardly visible, but this is the class. It has like, it's already a small one in a legacy context. It has 8 methods. And the interface for it, you can see down here, it says, yeah, you can see it down to the right here. That's the interface, it has 1 method. So if you are like me, you're not that smart as you think you are. Like for me, when I come and see this class, my brain starts thinking about all the things hiding behind those methods. Even if I'm not testing that class, even if I'm just trying to get something, I'm not trying to test that class, I'm trying to test something that uses it. But still, my brain starts thinking about how does this think, and what about this, and so on and so on. And you're spending lots of your energy reasoning about the methods you don't really care about right now. But like with the interface, you say, oh, yeah, okay, this is the single method. I can handle that. That's That's not causing a brain overload. Yeah. Oh, and by the way, if you don't understand some of these words, it's probably because we in our project use English for technical terms and Norwegian for domain. So don't feel bad about that. All right. Trick number 2: set your dependencies. This is also not rocket science, but it's worth noting anyway. It's like set your dependencies from outside. Use CDI if you can. Use dependency injection. Use inversion of control at least. Because this is a way to detangle. This is untangling in practice. Like you're taking one piece of the spaghetti out. Like you say, stating, okay, for this class, I'm depending on this and this and this. And then you can set those things to something you can control in your tests. So an example of this from the project I'm working on, yeah, just document manager, document generator. Here you can see that I also use the interface trick. Yeah, so just inject EUB. So in production code, this will be automatically injected, but for my tests, I can easily set these ones so that I can fully control what's going on when I'm unit testing my code. Yeah, an example from my tests. It's a bit high up there, but you can see that in my person manager, I'm setting the object store to an instance of object store that I control in my test. Yeah, and here's like a more legacy example. This is also from the project I'm working on. Like we do have some classes that have maybe some responsibilities, maybe a couple too many. But like we can test this called document varsling, document notifier, in isolation. Like we can control all the dependencies explicitly in the test. Yeah. By the way, singletons. I guess some of you saw that we had maybe recent into that we're using singletons. And yeah, I'm working on a legacy project. In a legacy project, things aren't necessarily as you want them to be when you get started, when you start a new project. So when you come into a project with lots of dependency, with a lot of singletons, well, you should know how to test singletons, or like how to handle them in your tests. That's a great tool to have in your toolbox. Like, oh, by the way, how many of you consider yourself not working on a legacy project? Maybe a few, yeah. Yeah. Of course. Yeah. No, you should know how to do this. Yeah. So it's like an explicit example of singletons from a test. You can say like, oh, we have a singleton in our project called code manager. So we like set instance to a fake code manager. Like it seems really simple, but you get into some challenges with parallelization. You get into some challenges if you're like mixing unit testing and integration testing. So beware of that. Yeah, my favorite trick, the one when think I'm using the most package protector problematic parts. Like if you got some part of your code that makes everything really hard to test, take that single part into its own method and set the visibility of that one to package protected. It sounds really simple. It sounds really like trivial, but it has helped me a lot to do this consciously. I'm using this a lot. Like the older the code, the more I tend to use it. And like doing this way, you can say, okay, this class that I'm newing up here, that's typically a problem in our code. So in my test, I'm overriding this. And you can say that, oh, but isn't this like making my design better, or like my design worse? You can say yes, but it's also indicating clearly to you as a developer that this class is doing too much stuff. Like here are some responsibilities that maybe should get out. And yeah, you can also use this technique if you got a package protected method in another class, another package, or another module or whatever that you want to do something with in your test, right? You can override it and expose it to your test class. Hopefully you wouldn't have to do that too often, but who knows? Yeah, so here's an example from a test. This is from a test class. You can say, oh, yeah, here overriding this getSQL method to return like some class variable SQL in the tests. So maybe the SQL from the real implementation was hard or throwing exception or like I don't know, but like in the test we can control it ourselves. All right, how many of you have used Mockito? Yeah, about half of you. That's good. Mockito is a tool it has helped me a lot to write my unit tests because it helps you create objects that you can fully control yourself. Like objects you can tell how to behave, and you can ask them, oh, what has happened to you? How have you been invoked or not invoked? Or like, and I'm not going to take a hard stand on whether you should use Mockito or not, or like whether you should use mocking at all or not. That's like a discussion in the unit testing world. Like, do whatever you want, but it's a tool worth knowing, and it's rather common and widely used, so it's practical to have it in your toolbox as well. But like my experience is that the older the code base, the more legacy you have, the more useful it tends to be. So a quick example for those of you that haven't used Mockito that much. Like here's an from one of the tests where I'm testing like we have a listener that wraps another listener that's useful in our project for some things. And I say that, the inner listener, that's a mock. So like I don't really care what's going on there. I'm just interested in how is it going to be invoked. And a mock that's a stupid object that just returns the Java default values unless you tell it to do something else. And void methods do nothing and so on. So like I mock that one. I call the wrapper method, the one I'm interested in. I'm calling that with commit cancel. And I verify that's a Mockito thing, like that the commit listener has been called with commit cancel, but it has never been called with commit succeeded with like any input, because it shouldn't be called at all. And of course, you can do much more advanced things than this. You can also use like spies. Like a spy is a version of a real object that Mockito handles for you. So you can say to that real object, "Oh, have you been invoked like this?" with verify, for example, or you can override specific methods or do lots of cool things. And you can also tell Mockito how to behave in different situations. So you can use things like do return. If you want to say, okay, if this object is called with 4 as parameter, then you should return this. Or do throw an exception if someone tries to do this. Or lots of cool things you can do. Or more advanced things. But there's a trade-off here. Like if you're doing very advanced things, then maybe you're being too smart, and you're causing brain overload for the next developer, or you're trying to do too much things in your test. Maybe you should consider writing an integration test. So yeah, there's lots of things to do, but like spend a couple of hours getting to know Mockito. It pays off. Oh yeah, here I'm actually managing to fill the entire cinema screen. I'm impressed, but like do return that says when sock manager, case manager, is invoked for the method create blah 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 blah, then return this object. So that's what I just said. Mockito can do these things for you. So spend a couple of hours getting to know it if you don't already. Yeah, consider removing final. As with mocking, I'm not going to take a stand on final later. Some people love it, some people hate it. Do whatever you want. Like using final can make testing harder. Like a final method or a final object, you can't subclass it, you can't override it, you can't use Mockito on it. So maybe you should consider like skipping final for now if you're having trouble testing that one. So yeah, this is a pragmatic trick. Like this is something you ideally perhaps wouldn't want to do, but well, if all it takes to get your code in the test is to remove this keyword, maybe you should do it. So in general, lots of things you can do to get code in the test is untangling, like taking your code apart safely in a slow manner. So, and like once you got your code under test, and like once you have it untangled a bit and you gotten code under test, then you can safely refactor, and you can refactor with shoulders low. And you can get this wonderful feeling of getting the legacy code under test. That's an awesome feeling. So that takes us further on into the principle, I think, that testable code tends to be good design code. Because like what I've been talking about so far, it has been ways mainly to make your code more testable, but also much of it improves your design. Like if you adhere to the single responsibility principle, that improves your design, but it also improves your testability. If you use dependency injection, I would say that improves your design. It definitely improves your the testability of your code. Like if your methods are short, that's good both for your design and your testability typically. And if you provide clear APIs, that's also cool. That's good for design, good for testability as well. And like in the entire solid principle pack or principle set, I'd say, yeah, improves your design, one might say. It definitely improves testability as well. And the same thing like variable names. If your variable names make sense, like first of all the other developers will thank you. But also it makes it easier to know what should I name my test. Yeah, okay. There should be probably be some connection between what you're naming your variables and what you're naming your tests. So ideally your test names also provides some kind of business value. I'll come back to that. So you may be a hero and writing a lot of cool tests and like testing everything, but if you're working in a team and you're the only one doing it, it only takes you so far. And what I've experienced is that when we started making it easier for the entire team to write tests, when we're like introducing helper methods or patterns for testing things we consider hard, then suddenly all the more resistant or reluctant developers also started writing tests because we made it easier for them. Like if you, in order to get a class and the test needs to do a lot of setup, a lot of instrumentation, and oh, you need to remember to do this and this and this and this and this to be like even able to instantiate the class you're testing. Then of course only the most like enthusiastic people will do it. So if you make it easy for the rest of your team to test, or like if you make it easy for them to make it easier, then you're in a really good path. So here's what we did in our project. Don't copy this blindly, but we created a test, an abstract class. We did and gave it a name that's were so obvious what it is that no one could misunderstand it. We did have some like halfway versions originally, so we named like abstract superclass for Lovisa unit tests. Lovisa is a project, by the way. So like, what's this class? Oh, you can't be wrong on that. So like this is typically things that we consider hard to do, like clear singletons or add object or create actor. That's part of that someone is involved in the case. And by the way, working in a project for Norwegian courts, so if you see some things that may give you some associations to legacy, not legacy, but law and lawsuit and the courts and so on, that's why. That's because that's our domain. So it's cool that you can actually see some traces of a domain somewhere at least. Yeah, but like after we introduced this thing, when everyone started using it, like yeah, you can handle the instrumentation here, and then in your test you can typically stick to the domain or like what you're trying to do. Ain't that hard? Yes and no. Like getting this started, it's just a simple Java class. So yeah, we just made it and started to use it. That like as we improved it and like several of us were starting to use it, well, more people started to use it, and then suddenly everyone used it. The hard thing proved to be to actually untangle the code, because like I'm working on a 15-year-old project, Java from 2003, still on Java Swing, but like Java 8 at least. So, but there's been made lots of code in that project that weren't made with code and with testing in mind, and I guess that's the case with like most systems, that not all code is written with tests in mind or testability in mind. So of course this didn't help us with that, but it helped us instrumentation, unlike it helped us be able to focus on the hard parts and not with the boring setup things. Oh yeah, this is a question. I've heard a lot of times, what are we really testing here? And if you're doing a lot of mocking, or a lot of setup, or a lot of instrumentation, you may very well, at some point, like totally forget what am I trying to test. And then you perhaps should stop and think, oh, what am I doing now? So yeah, we have asked ourselves this question in the project several times. Yeah, the more instrumentation you do, the more you should ask yourself this question: what am I really trying to accomplish? Am I really testing something, or am I just mocking here and there and everywhere? And like personally, I find that the way I can get rid of this project problem is to give my tests a sensible name. Like if my test tells me, the name of my test tells me what to do, well, then it's no problem. But of course, then I need to know what I'm doing, which I should be anyway. All right. Sometimes you have to write a lot of test code to get tests on your code. Sometimes it is hard. Like not all code is equal testable, as I said. But the important thing is that ain't a reason to like, oh, this code is untestable, I can't do it. Typically it means that, oh, maybe you haven't used the right techniques or some right tricks and so on. So give it a shot and like try hard to, like, so if you solve it once, then maybe the rest of the team can reuse your solution next time. Like look at how you solve that problem. Yeah, like, and especially if you do smart things like write a new convenience method or document what you've done or make the code a little easier to understand or in some way make it easier for the next guy to test the same type of thing, then you're on a happy path. But like, of course, there are some things that are extremely hard to test. There are sometimes you may be like crossing the border between what you should be testing and what's like doesn't give any sense to test. So you should, of course, at some point you should maybe pause and say, oh, am I really testing something now, or am I testing Java EE, or am I testing Oracle database, or like am I testing things that we don't have control over? And don't, if so, you can say, okay, I've reached the border, or this can't be tested, or we shouldn't test it, or like, but ask yourself the question first, am I really there, or am I just making an excuse myself? And maybe it's worth noting here as well, don't do stupid things, don't do useless things. Yeah. I've seen some tests in our project that were like, the name of the test was like, the name of the test was, oh, do some stupid test in order to get coverage in this code. And the entire production code was 800 lines of system out print line in order to increase the coverage. Don't do that. Okay, the next tip, back to the tips. Tip number 6, automate your builds. I really hope you have done this already, that you already have in the automated builds. But one thing we have learned here is that make sure that your tests are running in the automated builds and make sure that you follow up. If they are failing, do care about it. Really do care about it. Because we did a major mistake here. A couple of years ago, we had some tests that were failing and failing and failing, and we didn't do anything about it. So we were getting used to have a failing build. And what happens then? Yeah, exactly. Developers start losing trust in the tests, and when something fails, they tend to think that, oh, it's the same, it's a test that were already failing, it's not my stuff. And it has taken us a lot of time to get that confidence, the trust in the test back after that. So if your tests are failing, take care of it. Fix them, delete them, ignore them, like do whatever, but don't let them be failing. Investigate what's going on. Why are they failing? Are your tests wrong? Are your production code wrong? Do you use a dependency that has changed? Look into it. And that leads me to the next things. Like one problem is those tests that are always failing. But what about the flaky tests? Because you will inevitably I think, have some flaky tests that are really annoyable. You have a test that's failing, like it's failing 1 out of 10 times, 1 out of 20 times. So yeah, like a general idea is that your tests should be entirely stable. If some tests aren't, then you should handle it and make them stable. Or you can take those that are unstable and make a separate build for them or anything. Don't let the flaky test stop your flow. So you may would spend some time stabilizing them, the flaky tests. All right, step 7 or trick 7 that I hope that is supposed to many of you already using feature toggles. Feature toggles are in itself a trade-off. It's a trade-off between the flexibility it introduces to you and the fact that you have to write or handle more code. But feature toggles, you can make use of them on the testability side. You may want to have have a menu that's available for testing only in specific environments or for specific users. You may want to have exactly feature toggles so that in your test environment you can turn it on, but in production you have it off, or the opposite. Or you can have a property which says which environment you're running on, but be careful about that. So an example from our code, as I said, we're using swing, and swing utilities invoke later. That invokes the code in the runnable whenever swing is ready to do it. And that's fine in production code, but in tests, in unit tests, you want them to be predictable. You don't want to wait for the swing thread to carry on. So we introduced this. We introduced this if here that says if it's headless. Headless is a Java thing that I guess some of you know, that it's a setting that throws an exception if you're trying to open a graphical window or wait for key user input or so on. That's a great way to get your tests stable and ensure that they're not stopping. So, but if the code is the environment is headless, then you should just run the runnable at once. And then you get it stabilized. And this is a kind of feature toggle. You can of course use more regular feature toggles, but this is an example. Yeah. So I've spoken a lot about unit testing, but of course integration tests are fine. Integration tests are great. You should have them in your toolbox as well. You should even have some of them in your project. But if you're doing integration testing with an external endpoint, don't use the real one. Don't use the production endpoint. We're doing that actually in one of the dependencies we have. It's causing us lots of brain trouble. Like we have to be so really careful, because what we're doing is we're sending it to the real production endpoint, but with specific keyword in it. So everything with that keyword goes into an inbox that no one does anything with, luckily. But don't do that. Your test leaders will be stressed and scared. So what you can do instead is, ideally, the third party provides a test endpoint. Use that. Or if they don't, make your own endpoint. Make your own test endpoint. There are mocking tools for that. Or you can, maybe use a feature toggle or anything that just disables it in your test. But don't invoke the production endpoints. Yeah. A pattern that many of us tend to adhere to, either consciously or not, is, we have one production class, then we should have one test class. And perhaps it's ideally that way, but in practice, in a legacy project, classes tend to have lots of responsibilities. In our project, we have quite some classes that have responsibilities. You can count them like 1, 2, 3, 4, 5, 6, 15 responsibilities in one class, right? That's not, we have some of them. But then you can perfectly fine have several test classes for one production code class. Of course, it's an indication that your production code ain't properly divided, but that's not a surprise in the legacy code. So even if you can't right now divide your production code, you can divide your tests. Or maybe you can divide your production code as well. Because if you find out, this suggests that we should have a single test class for this part of the production code. Maybe that can be another class as well. So it's an indication, it's a direction for you if you want to untangle your code. Yeah, but the most important thing of all, the most important tip I can give is just start. Like, start to test your legacy code. Get started. Don't wait, but just keep going. That way, you'll learn a lot of things yourself. You will learn what you need to do in your project. You will learn the tricks that is nice on your code base. Because I believe there's lots of truth in the saying from the continuous delivery world that if something is painful, do it more often. You will learn. You will get better at it, and it will work on your project. Lots of people said when we started that it could never work on our project. We did it. It did. So beware of limiting beliefs. Well, a couple of times they were right. We tried to do things that couldn't work on our project and didn't, but that were the exceptions. But it's typical, like as you're staying in a project, you get to know the code base, you get to know, you're getting comfortable with how it is right now. Like changes start to sound hard, challenging. I don't want to change anything. You get into that mindset unless you're conscious about it. So maybe we should start asking the people that are new to our project, okay, what are we doing wrong? What are the things we are doing that you are thinking, whoa, why are we doing this? This doesn't sound smart. Ask the new members of the project that. Yeah, okay, I can't speak a lot about this, but like you get what you measure. So if you measure test coverage, then you get those methods I talked about earlier with 800 lines of system out print line in order to increase the coverage. But maybe I don't think our team was major for us to talk about a lot about test quality when no one were actually writing tests. So we took a conscious choice to speak a lot about test coverage. Speak a lot about, oh, okay, we're testing all our code. We're testing all our code over and over and over again. And then people started writing tests. Of course, not all of them were good. Many of the tests we have are like suboptimal at best, but at least they are there and people are into the idea, the mindset of writing tests, doing something or not. So that's the first step. So next step, increase the quality. But what I've learned from that is that people do adjust into what you're measuring and what you're speaking a lot of, people will start to consider. Yeah, but tests are also a Swiss Army knife. Tests provide lots of cool efforts and cool functions for your code. So they have documentation. They are like a functional introduction to the domain. They tell the story about your domain. Ideally, though, they're a safety net against regressions coming on when the next guy is changing the code in 5 years. They're a pathway to shorten those system test phases that were going on for 3 or 4 weeks that none of us liked. So if you have a long system test period, you can probably shorten it by writing tests instead. And they are an inspiration to your colleagues that, of course, you can be tested. Yeah. So the one thing worth mentioning here is that we at our project are consciously following the Boy Scout rule. Every time we change some code, we do it a little bit better. We improve the code just a little bit. If you do that consistently, every time you change something, you improve it. Then you will get to a better system, and then you will get your code under test as well. If you every time you change something, write tests for the surrounding code, for example, that helps you with improving your code base in a safe way. All right, I promised to say a little bit about test-driven development. How many of you do test-driven development today? Yeah, some of you. That's cool. Test-driven development is awesome. You write the test that's failing, you're fixing it, you're refactoring, and you're writing more tests that's failing. Oh, and this is so cool because it makes you write tests without hardly even noticing, and it gives you immediate feedback. You write easier code, and you skip the point and click part to a large degree. Okay, so that's test-driven development. I guess that's not a new concept to anyone, but test-driven spaghetti, test-driven development in a legacy project. Can we do that? How can we do that? Well, what I tend to do is that I get the method itself under test. So before I do anything, changes to the production code, legacy code that is, I write a test for the method that I'm going to change. And I see that, okay, this test is just running through the method as is. And when I get that one functioning, then I add an assertion, or I add the test part, and then I fix that one in the production code, and then I refactor, and so I keep going. So getting legacy code under doing test-driven development on legacy code is actually doing test-driven development and getting legacy code under test. So it's just those two parts combined. It's quite fascinating because it ain't actually harder than that. Of course, it's hard to get legacy code under test, and you may need a lot of tricks for it. But if you want to do test-driven development, that's the only thing that's harder than doing it on a greenfield project. The TDD part itself works perfectly fine. So there ain't really a big difference there. But the one technique I tend to use a lot when I'm doing TDD and changing legacy code is to split things up. Like extract method, extract class, this package protect the problematic parts trick I mentioned earlier on. All of these things I tend to do often when doing TDD, like maybe more often than when I'm not, but yeah, that's a great trick. Or you can use more advanced things like mock the entire class and do some Mockito tricking, or it depends on how hard your code is, of course. Alright, so for those of you that want to know more or are interested in learning more about how can I test my legacy code, what tricks can I use, or whatever, or this is an exciting topic, I want to learn more about it, or I might need some more tricks, because there are lots of more things in the toolbox that I haven't spoken about today. I first of all suggest that you read through these two books. Michael Feathers, Working Effectively with Legacy Code. Awesome book, lots of tricks. And the same, Martin Fowler, Refactoring. These are both classics, I know, so maybe many of you have read it already. But Refactoring, I think it's a coming new version this autumn. Looking forward to that. Great books. You can also have them near to your desk, and when you need it, you can pick it up and find one specific refactoring or trick or whatever you want to name it. But also Twitter. There's a lot of exciting, interesting tests discussions going on Twitter. So I mentioned a couple of those that you should follow. Lisa Crispin, Elizabeth Hawk, Angel Jones. These are just some of the test gurus that are on Twitter and doing lots of interesting test discussions. If you follow these, then you suddenly get to discover lots of other people as well. That's a great area to get to know more. But most of all, do it yourself. Get your own experience and solve the problems as you turn into them. Okay, so what are three key takeaways I hope that you take with you today? First one, good design improves testability. Second one, sometimes you may have to compromise. You may have to do some trade-offs. After all, it's a legacy code. The third thing I hope that you take with you is that it ain't too late. If you're not trading tests on your legacy code already, you can start today. That's great. That leaves you in a better state tomorrow. And if you feel free to to reach out to me and contact me on Twitter or here or whatever. If you want to share some more tricks or get some discussion about it or anything, I find this topic really exciting. So I guess that many of you have problems in your code bases that we don't. Yeah, so with that, I say thank you for your attention. Vielen Dank.